All right, welcome to the second lesson in this first unit in advanced in 3U functions. Just want to take a second just to say the purpose of these videos is really not to replace the classroom. In this case, if you're taking this online, then potentially it is, but there's always help. There's always ways to ask questions. You can always reach out and ask those questions. And I understand that it's not always the most exciting thing, and so I try to make them as quick as possible. Feel free to pause, rewind, rewatch something. I know some students really like them to go back to for tests, or just to reiterate a concept. Maybe I said something in class, but you didn't really catch it, and so I'll probably say that in the video too. So you can rewind and fast forward. So I'm trying to make these what they are. Really, it's just another way to get a resource outside of class. And this is one resource. There are other resources online as well, and feel free to check out anything you can. I do find these very helpful for students, and it's helpful for students if they miss class. But always remember that if there's something you don't understand, you can rewatch it. You can check out something else online. Or you can just come in for extra help, however that looks. That'd be tutoring, help with me, whatever it is. Okay. So this is a question that would be on the board when you come in. So it's something that we haven't really seen before, and so we're going to start to look at it. So today is about function notation, and so I want you to look at this and think about what f of 5 might be. So just take some time and think about it. Because if you can figure this out, you've got a good idea of what we're going to be doing in this class today. So if you guess that if you plug in the number 3 and you get 7, you can see that would totally be correct. Subbing in 3 gives you 9 minus 2, which gives you 7. So given the example, we're guessing that you're going to do the exact same thing for f of 5. This is the notation that we're going to use in this class. It just says sub in 5 for x, where x was. So you don't have x anymore, we have 5. And the input's 5. It really emphasizes that we've got an input, we're going to sub that in, and we're going to get the output of 13. If you caught that, you basically get what we're going to do today. And so we're going to work through some examples like that. Learning target 2, I know that function notation is used to describe inputs and outputs, and I can evaluate or simplify expressions using function notation. So this is something we would have done in like grade 9, where we've got a music downloads site, 50 cents per song, plus a one-time membership fee of $10. It's not outside the realm of possibility that this would be a website. This is not really that dated. That could be the possibility. I know that Google Play charges a membership fee, and then you can download whatever you want. You can listen to whatever you want. I personally just like to pick songs that are on sale, so I'll be listening to anything that's cheap and popular, and that's probably what's good anyway. And so I'll just download random songs. Some songs I won't download, like I haven't downloaded Renegade yet, because every time I turn on the radio or the TV, you got the commercial, ex-ambassadors, and so it just plays all the time. And so I know that this video will be dated at a certain point, and that song will be gone. But right now, I just have no need to download that song. So using traditional variables, it would look like this. Y equals mx plus b. 50 cents would be the slope. 10 would be the y-intercept. We start at 10 and we add 50 cents every time. We do specify what those variables represent. X is downloads, Y is cost. That's important. It's something we forget. But when we're describing a model, we do have to say what the variables represent. Using function notation would look like this. F of x equals 0.5x plus 10, where f of x is cost and x is downloads. We don't have to use f all the time. We could use capital C for cost and a little d for downloads. I just want to kind of expose you to this a little bit at a time. Okay. So you can see it's basically the same thing, except y has actually been replaced by this expression f of x. It doesn't mean f times x. A lot of people kind of get that confused when you first start, but it just means f inputted x. Like we're going to input x into it. So really f of x, the f does not work without the x. Function notation, which is just hidden, I'll just not click. Function notation highlights the fact that cost is dependent on an input, which is downloads. Try not to keep my mouse in the middle of the screen. I know that can be distracting. In general, we see this. You don't have to write this down. It's in the notes. This represents the dependent variable. We used to use y. It reads f of x or f at x. And just emphasizing the input and the output means the value of the function, the output for a given input. You can see the input x is inside. And that'll help us understand transformations as well. Over the semester, we'll use different notations. It doesn't have to be f. It could be g, h, v. And they all really help you because they represent different types of functions. So if we had a whole bunch graphed on the same grid, we could call f of x1 and then g of x, then h of x, and we're going to see that just in a second here. Versus what we had, which is just y, and then we called all of them y, it doesn't really make sense. Just a quick example, just to show you the input and the output. If you sub in, if the function is 2x minus 3, you sub in different x values, you get out different y values. And it doesn't mean that you can only sub in these numbers, like you can sub in decimals between, and so this becomes a straight line. And so just emphasizing, if you sub in -2, we get -7, which we can't see. If we sub in 0, we get -3. If we sub in 1, we get -1. Sub in 2, we get 1, and then so on. 4, we get 5, and so on and so on. And that's a linear function, just a line. I know you have like y is function notation necessary, but we'll do that in a second because this helps with one of the reasons why it's necessary. So given two functions and they're different, one's represented f, one's g, we got to answer these questions. If you want to do that on your own, you can, just to kind of play around with it. Or if you just want to follow through, then that's fine because you'll have practice after. So this means take the output when we sub in 5 and take the output when we sub in 5 and subtract them. So we could do those separately or we could do them at the same time. But the output when we sub in 5 is 10 for f, and the output when we sub in 5 is -9 for g. And if we do 10 minus -9, we get 10 plus 9, which is what these two outputs, that's what this means, is subtract the two outputs. And so you get the answer of 19. Remember, when you subtract negative, you actually go up, like it gets warmer. Subtracting cold, subtracting debt, it's a good thing. You're adding. This just means double the function, so take the entire function and double it. So we just put the 2 in, and we can multiply the 2 by both of the terms inside the brackets. And so we're just double the function and we get a new function. Okay. This means don't sub in an input of x, sub in an input of x minus 2. So in general, subtract 2 to the inputs. So we do that once, and then we can sub in the general values after. So we sub in x minus 2 in for x. So the x is replaced with x minus 2. We distribute the -2, combine like terms, and you get 5 minus 2x. It's always helpful to simplify it, even though it doesn't ask you to simplify it, just so that we can see, all right, now if we sub in an x value, we can get outputs. And this means add the two functions together. And so we just add the two functions, combine like terms, and we get, brackets don't really matter. I like to put the brackets when I sub something in. Here it doesn't matter because plus, if it was minus, they would, because it would distribute. And so if you think about the plus distributing, it doesn't really change anything. And we just combine like terms. So why is it necessary? So it allows you to do something with the output without having to find out what the output is. And so that's actually going to be shown in here. We didn't actually need to know this 10 and the -9. It could have done it itself. In programming, it allows you to do more complicated functions, which will use multiple functions. We actually saw that in the Garfield example. And so we're just allowed to do more, like really cool things, without actually having to like see what the function is. I'll put another YouTube video that I made up for that if I can, and then you can see another example in Alice. I just wanted to show you an example in Excel. Sorry, that's a YouTube video. So you can watch that YouTube video. It's just an example in Excel. It really works through that last. It really works through this in a lot simpler way, and especially if we change the 5, we don't want to do that work all again. And so the Excel example works through that. If you're not familiar with Excel, it is a good thing to get familiar with. And so I kind of walked through a little bit about that, so it's good to watch. Domain is this is just something that comes up in the homework. We're going to spend more time on it tomorrow on the next lesson. Domain is defined as the set of all independent variables. So it's all possible values for the independent variable. Range is the set of all possible values. It should say values here for the dependent variable. And so we state the domain and range. This is actually a parabola. So domain can be anything. So we say just all numbers, and we'll tighten that up a little bit in the next lesson. And the range is all numbers greater than or equal to 0. If it's a parabola, because you're squaring it, you'll never get any negative numbers. You can get 0, but you'll never get negative. And we'll tighten that up. It'll be a little bit easier after we see it, but I just want to start to like introduce the concept of domain and range. This next one is a line. It's easier if you see the picture, but you should also think about it with the equation. The domain is all numbers you can sub in, and the range is all numbers too. You can sub in anything for g of x and sub it and solve for x. So a line has any values for any outputs that you want. There's an input that would get it. So all numbers in both cases. This guy, we're not sure what it looks like yet. We will see that in this unit. But it's a square root. And so the problem with square rooting is you can't take the square root of a negative number. So the domain is all numbers greater than or equal to 2, and the range is all numbers greater than or equal to 0. Any number greater than 0 you can get as an output if you figure out what the decimal input is. But you can't get anything, and you can't get negatives when you square root. That's why we do the plus and the minus on the outside, but that's not here. And you can't square root a negative. So you can only square root 2 minus 2, 3 minus 2, 2.0, 1 minus 2, all those kind of things. Anything less than 2 is not allowed. There's some practice, very minimal domain and range stuff. So I would worry about, we'll talk about that more in the next lesson. But if you can just work on this, some of the function notation stuff. Okay.